Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the topic about applied statistics, in the previous sessions we were talking about index numbers, analysis of time series, control charts and statistical quality control. In continuation with the discussion about control charts, we were also discussing about various acceptance sampling plans. In continuation with that, in this session we are also going to talk about acceptance sampling plans. In connection with that, some more concepts of AOQL, average outgoing quality limit, and ATI functions are to be dealt with. So, just a recall is necessary for going ahead with in this session, that is acceptable quality level AQL is a % defective that can be considered satisfactory as a process average. So, these topics have been already covered, it is just a recall. And next is lot tolerance proportion defective, that is LTPD. It is the lot quality which is considered to be bad by the consumer. Next terminology is average outgoing quality, that is AOQ. It is actually the average quality of the product after sampling and 100% inspection of rejected lots are considered. Next terminology is ATI, that is average total inspection. It is the average amount of inspection required for the rectifying inspection plan. In continuation with that, one more concept is average outgoing quality limit, that is AOQL, that is the expected fraction defective remaining in the lot after the application of the sampling inspection plans. So, after studying these terminologies, we have got to study some more concepts of OC curve and ASN, that is OC means operating characteristic curve and average sampling number. So, these are the 2 more concepts to be studied further to complete the acceptance sampling plan study. In general, if P is the incoming quality and a rectifying inspection plan called for 100% inspection of the rejected lots is used, then the AOQ, average outgoing quality of the lot, will be given by the formula AOQ is equal to small p into small p is the incoming quality and this is a proportion defective, PA of acceptable proportion defective, PA of P plus 0 times 1 minus PA of P. This is equal to P into PA of P. Okay. From this equation we find that if P is equal to 0, the lot is 100% okay. That is AOK, average outgoing quality is 100% okay, then AOK becomes 0. Suppose if P is equal to 1, that is this P is equal to 1, then we have AOQ is equal to just PAP and that is the lot is 100% defective, then PAP is equal to 0 and so AOQ is equal to 0. So, that is if P is equal to 0, AOQ will become 0 because of this small p. If P is equal to 1, then AOQ is equal to just PAP because P is 1, no. So, PA of P, and if this P of P becomes 0, then AOQ also will become 0 and we say that the lot is 100% defective. So, there are only 2 possibilities, one is 100% okay and 100% defective. 100% okay is appearing in the case of P is equal to 0 and 100% defective will appear in the case of P is equal to 1. The other values except 0 and 1, that is other values of P lying between 0 and 1, when 0 and 1 excluded, then AOQ will be positive and will have a maximum value of some value of the incoming quality P. The maximum value of P subject to the variation of P is called the average outgoing quality limit. It is represented as a PL. Its short form is AOQL. Okay. And it is given by the formula. If Pm is the value of P which maximizes this maximum value P tilde subject to the variation of P, and if Pm is the value of P which maximizes this P tilde, then we have a PL, that is the average outgoing quality limit. Average outgoing quality limit AOQL is given by the formula PL tilde, and it is the formula Pm into Pa of n minus n divided by capital N, where capital N stands for the whole lot size and small n stands for the sample size, and Pm is the value of P which maximizes P, and it is Pa of that is probability of acceptance is taken over n minus n, where it should be remembered that Pa is to be computed for P is equal to Pm. Okay. And then we have rewriting this equation again, we have AOQL becomes is equal to y by n into 1 minus n by capital N, where y is n Pm into Pa. Okay. That capital N minus n by n is taken into account, and multiplying and dividing by n, it happens like this. You just multiply and divide by n, n Pm of Pa into, take this capital N outside, and it becomes 1 minus n by capital N. Okay. Take the capital N outside, becomes like this, and this n Pm, what is that? N Pm of Pa is becoming like this, this is y, and the whole thing becomes y. So, you have y by n into 1 minus that n is already there, no, that gets cancelled. So, n Pm into Pa is represented as y. So, it becomes y by n into 1 minus small n by capital N. This y values n Pm Pa has been tabulated by the famous Dodge and Romig for tables for various value of n, that is a sample use, and C acceptance number of sampling plant, that is maximum allowable number of defectives in the sample. This is the Dodge and Romig single sampling lot appearance lot tolerance tables, and it is given for various values of n, c and AOQL percentage. The process average is given in percentage, and you have a capital N values. Lot size is from 1 to 30 and small n values are given. C is the number of defectives allowed, maximum number of defectives allowed, and this is AOQL percentage. Likewise, the values are tabulated here. This is what is Dodge and Romig tables for various values of n and c. Now, this AOQL measures the long term protection given by the plan to the user in the worst situation, it is in the very bad situation. Okay. Now, we have used the terminologies AOQ and AQL. AOQ is average outgoing quality, and AQL is average quality limit, and AOQL is average outgoing quality limit. Now, it may be pointed out that AOQL curve for various values of PL plotted against P will reach a maximum value and then recede. Since the poorer the quality of the incoming product, that is the larger value of P, fewer lots of will be accepted and more will be inspected 100% and made acceptable. So, now it is like the AOQL curve, after reaching its maximum it will recede, that is it will go downwards because when the incoming quality is becoming poorer, then that lots will not be accepted, only few will be accepted and the remaining will be sent for the 100% inspection. The bad lots which is not accepted will be sent for inspection and then it is made acceptable. After studying about AOQL, next in continuation in the series, we are going to study about OC curve. OC curve means operating characteristic curve. Okay, operative characteristic curve of a sampling plan is a graphic representation of the relationship between the probability of acceptance P alpha, or generally denoted by L of P, for variations in the incoming lot quality P, that is fraction defective in the lot. Then next terminology is ASN, that is average sample number. Now this number is the expected value of the average, stands for the expectation. So it is the expectation of the sample size required for coming to a decision about acceptance or rejection of the lot in an acceptance rejection sampling plan. Okay. So it is kind of an average of the sample size, whether to accept or reject the lots in the single sampling plan. Obviously, it is going to be the function of the incoming lot quality small p. We have been studying AOQL, OC, ASN, and then next ATI, that is average total inspection. On the other hand, when the expected number of items inspected per lot to arrive at a decision in an acceptance rectification sampling inspection plan called for 100% inspection of the rejected lots is called average amount of total inspection. It is the number of to be inspected. When the incoming quality is poor, it goes back for inspection and made acceptable. That number, that expected number of items inspected to arrive at a decision in an acceptance rectification sampling plan, wherein the situation is like 100% inspection of the rejected lots is there. Okay. That amount is called average amount of total inspection. Now obviously this ATI, average total inspection, is also a function of the incoming lot quality P, and we observe that ATI is equal to average sample number plus average size of inspection of the remainder in the rejected lots. Thus, if the lot is accepted on the basis of a sampling inspection plan, then ATI is equal to ASN. If it is not accepted on the basis of sampling inspection plan, then ATI will be definitely greater than ASN, that is ATI will be equal to ASN plus some quantity. We are discussing that some quantity is that average size of inspection of the remainder in the rejected lots. Now for example, in other words, ASN gives the average number of units inspected per accepted lot. To be elaborate, for example, if a single sampling acceptance rejection plan is used, then the number of items inspected from each lot will be the corresponding sample size n, that is ASN is equal to small n, and this will be true independently of the quality of whatever the lots being submitted. However, for an acceptance rectification single sampling plan calling for 100% inspection of the rejected lots, additional capital N minus n items will have to be inspected for each rejected lot, where capital N is the lot size, because small n will appear for the acceptance rejection plan and it is considered to be inspected in the single sampling acceptance rejection plan. Whereas when a small n items are out of capital N, then remaining is capital N minus n items that will be inspected in an acceptance rectification single sampling plan, okay, which requires 100% inspection of the rejected lots. Thus, in this case the number of items inspected per lot varies from lot to lot and is equal to this small n if the lot is accepted and is equal to capital N if the lot is rejected on the basis of a sampling inspection plan. The average amount of total inspection is a function of the lot quality P and is given by ATI, average total inspection, is equal to N into L of P plus capital N into remaining 1 minus L of P, where L of P is equal to PA of P is the probability of acceptance of the lot of incoming quality P on the basis of sampling inspection. Now, rewriting this equation, just rewriting, you can just call it as 1 or so. Rewriting this equation 1, we get ATI is equal to N into L of P plus capital N minus adding and subtracting small n plus n into 1 minus L of P, and then capital N minus n into 1 minus L of P is written here, plus n into 1 minus L of P is written here. So, that these two are clubbed, n into L of P plus n into 1 minus L of P is clubbed, and you can just cancel n into L of P, and there remains n plus capital N minus n into 1 minus L of P. This is the formula for ATI. After studying about AOQL, OC, ATI, ASN, next we will talk about a sampling inspection plan for attributes. Attributes we have already studied in one of the subject. Attributes is an quality or characteristic of the item considered. Now, what are the various sampling inspection plans for attributes? The commonly used sampling inspection plans for attributes and the count of defects are single sampling inspection plan, double sampling inspection plan and sequential sampling inspection plan. That is, out of these three, we will go deeper into the study of a single sampling inspection plan. This single sampling inspection plan, what is it about? If the decision about accepting or rejecting a lot is taken on the basis of only one sample, then the acceptance plan is described as a single sampling plan. It is completely specified by three numbers. What are the three numbers? Capital N, the lot size, small n, sample size, and C, the number of defectives. C is the acceptance number, that is maximum allowable number of defectives in the sample. The single sampling plan may be described as follows. First of all, you have to select a random sample of size small n from the lot of size capital N. Inspect all the articles included in the sample and then represent the number of defectives in the sample as small d. If this d is less than C, because C represents the maximum allowable number of defectives. If your number of defectives is less than the maximum, then we can accept the lot. So, this is what is the plan. If D is less than C, accept the lot. If D is greater than C, reject the lot. This is what is called a sampling plan, a single sampling plan, because it is based on only one sample. That is, D is less than C, accept the lot, in the sense replacing defective pieces found in the sample by non-defective standard ones. Okay. In this case, if whatever the defective items are there, that will be replaced. If you are having D, that is number of defectives in the sample, is more than the maximum allowable in number of defectives, then we have to reject the lot. In this case, we inspect the entire lot and replace all the defective pieces by standard ones. Flow chart of a single sampling rectification plan. What is that? It is all based on a D and a C value. Okay. First job is to inspect a sample of a size n, okay, and D is the number of defectives in the sample. compare this D value with the C. Okay. If D is less than or equal to C, then accept the lot. If D is greater than C, then reject the lot, and it goes for 100% inspection. The flow chart elegantly displays the single sampling rectification plan. It is actually, the single sampling plan is very simple and is easy to understand, design and carry out. The basic problem in administering the single sampling plan is the choice of n, sample size, and C, acceptance number, maximum allowable number of defectives, which have to be determined in advance. The most economical single inspection plan is a single sampling inspection plan is obtained on minimizing the average total inspection, that is ATI, by providing adequate protection to consumer and producer. So, Dodge and Romick tables have prepared extensive tables for minimizing values of N and C for the consumer's risk. Consumer's risk means accepting the bad ones, isn't it? So, beta is equal to 0.10, and for different values of P, the process average fraction defective. Now, as we have discussed, we have to set up the values of small n and C in advance, so that the single sampling inspection plan will be carried out more efficiently. So, how to determine the values of n and C? First of all, the lot size capital N is invariably known. The two unknown quantities that are to be determined in the sampling plans are n and small n and C. In a lot of incoming quality P, the number of defective pieces is NP, isn't it? And non-defective pieces is capital N minus NP. NP is defective cases, means non-defective out of the lot, capital N is N minus NP, that is written as N into 1 minus P. So, the probability of getting exactly X defectives in a sample of size small n, size A, from this lot is given by the hypergeometric distribution G of x comma P is equal to NP Cx into N minus NP C n minus x NPCx, it is n minus NP C. C is actually the combination, like NCR we did not use to write, no. So, that NCR is written here as a capital NPCx and capital N minus NP C n minus x divided by NCN. From the lot of size capital N, a sample of size small n is drawn. So, capital N C n and x stands for the number of defectives. So, therefore, NPCx, and from the remaining lot n minus NP, from the remaining non defectives n minus NP, n minus x are chosen. So, small n minus x is chosen. So, we have n minus NP C n minus x. Okay. So, the probability of accepting a lot quality of small p is given by PA of P is equal to summation x is equal to 0 to C, because maximum allowable limit is C. G of x comma P is equal to summation x is equal to 0 to C. Just write this formula, NP Cx into n minus NP C n minus x divided by NCN. Hence, the consumer's risk is given by PC is equal to probability of accepting a lot of quality Pi. In this case, we have summation x is equal to 0 to C G of x comma Pi, and in that case it becomes summation x is equal to 0 to C n P I C x and n minus n p I C n minus x divided by n C n. To protect himself against poor quality, the consumer usually demands a small value P C for a given P. So, the producer's risk is given by P P is equal to a probability of rejecting a lot of quality P bar, okay, and it is equal to 1 minus probability of accepting a lot of quality P bar, okay, and in that case the probability is given by summation x is equal to 0 to c n P bar C x into capital N minus n P bar C n minus x divided by n C n. Okay. In this session, after recalling the various concepts related to acceptance sampling plan, we talked about the concept of average outgoing quality limit AOQL, average sample number ASN, average total inspection ATI, and operating characteristic curve OC curve. Okay. Also, a single sampling rectification plan for attributes is discussed along with the flow chart. Determination of n small sample size and the C maximum allowable number of defectives is determination of this n and C is also discussed in this session. Based on the discussion in this session, the following questions may be posed. Explain the terminologies AOQL, ASN, ATI and OC curve. Next, how will you determine the n values and C value in a single sampling rectification plan? Thank you.